So for example number 1, we're going to be solving for displacement. Here's the question. Standing on the edge walk platform of the CN Tower, a student throws a penny upwards at 12 meters per second. If the edge walk platform is 356 meters above the ground, what is the height of the penny after 7.5 seconds? And as always, we're going to ignore air resistance. So in this case, I can start by writing my axes. In this case, I'm dealing with motion that's up and down. So here's up, here's down. And I'm also going to define a direction. So I'm going to choose arbitrarily, positive is up and negative is down. If you chose different directions, that's okay, just stick with the ones you chose. In this case, we're given not a displacement, but we're given an initial position. So that means we're going to have to define an origin. Since we're given the height of the platform above the ground, it makes sense to define the origin as the ground. And so that would place our initial position, position 1, 356 meters above the ground. That's position 1. We're also told that at position 1, the initial velocity of the penny is upward. So that's v1, our initial velocity. The other piece of information that we know, even though we're not directly given it, is acceleration due to gravity, and that's down. So in this case, we can start defining what we're given. We're told v1 is 12 meters per second up. We define up as positive, so that's positive 12 meters per second. We know that the acceleration is 9.81 meters per second squared down, and so that's equal to negative 9.81 meters per second squared. We also know d1, the initial position, is 356 meters up, and so that's positive 356 meters. We're going to have to select, oh, and we're also told the time. The time is 7.5 seconds, and we want to know where is that penny, what is the height above the ground after 7.5 seconds. So that second height is its second position. So now I've got information involving position 1 and position 2. Position 2 is what I want. I know the time, I know the acceleration, and I know the initial velocity. So I can go to my list of kinematics equations and select the one that allows me to solve for what I need, and it's this one. v1, displacement equals v1 delta t plus 1/2 acceleration times time squared. Now you might think, oh, not all my variables are in that equation. Well, let me just rearrange displacement in terms of the change in position. Now I've got all of the variables in this equation. So I can substitute in some numbers. d2 is what I'm really interested in, so I'll isolate it. d1 was 356 meters. v1 was 12 meters per second. Time was 7.5 seconds. Plus 1/2. Acceleration is negative 9.81. And the time again is 7.50 squared. When I evaluate that line, that expression, I get 170.1 meters as my final position, position 2. If I look at what I'm given in terms of significant figures, I'm going to be rounding to the ones place in the end. So that means my final position, d2, is 170 meters. Now, this is ambiguous, where the significant figures are, so I'm just going to draw a little arrow to the 0. Alternatively, you can also write that in scientific notation to make sure that it's not ambiguous. So my final statement will be, therefore, the penny, and I'll write it in scientific notation now, is 1.70 times 10 to the 2 meters above the ground.